All right.
Okay.
So I'm gonna start. So let's just itemize the use cases that Charles you mentioned already.
Um,
Do we
here
want to separate it by use case and by environment?
Well, let's do environments first.
Okay. So we obviously have CLI applications.
Hmm.
We have um, browser, like in browser.
They're called TUI apps. Browser. Uh-huh.
hmm We have like long running cloud hosted applications. We might have what's the word for them? Like the Lambda function equivalent. I don't know if there's a
Like edge edge
edge
function.
functions. Yeah, edge
functions as
functions.
a service.
Yeah, functions as a service.
Oh yeah. Yeah. Um, Anything else that comes to mind?
Probably need to at least account for like Node, Dino, Bun,
Mm.
V8, JavaScript core. I mean, those if we do things right, pretty much get those for free. But it's at
Hmm.
least I would even maybe just put them as one bullet point. Uh, yeah.
Okay. And so let's do the use cases. Um, so what is the
I think the
I think the
level
one, I
one
mean, for
though.
me,
Yeah.
huh?
Go, go ahead. Go ahead.
For me, the major, the biggest, I'm going to be coming from the perspective of teaching people how to use Affection. So for me, most of the use cases are going to be, um, like just like what the process is doing. So just being able to like um, see the structure,
Mm-hmm.
and like observe it changing.
Mm-hmm.
Um,
Uh,
yeah, go ahead.
uh, like with the debugging that I've done with the backstage inspector, like in backstage, that those were extremely helpful. Just being to see like what tasks are out there, like what background tasks are running. Like this is seeing the structure. So I'm just kind of reiterating that. But I was also saying like being able to view the logs in a like focused way.
Um,
So like like backstage for example spews out thousand log messages per second. um,
okay.
and so but what I'd like to say is I want and I wanted to be like and the v2 inspector could not do this. um, I would like to be able to be attached to a process and say um, I want to see the GitHub ingestion logs and and like under like the GitHub ingestion task and
Hmm.
and only those logs are showing in my inspector.
Yeah, it's definitely my main use case too. I think like
Mm-hmm.
filtered subset of the tree,
So you want to be able to filter the tree itself.
or at least just focus on because usually you have the full tree and you can kind of just by knowing your code and looking at the error pre-filter it and know what part of the tree that you need to look at.
Mm-hmm.
But like
Mm-hmm.
really digging down into that, like that one branch,
Mm-hmm.
determining which paths and what's happening there is where it would be valuable, and slowly cut off branches as you know it's not happening in that part of it.
Mm-hmm. I think it would be and this is the last. I'm gonna mention this, and then I'll let other people talk. I would like to be able to interact with the running tasks, because in a sense they are like little embedded programs. So like restarting, like in Simulacrum, to like be able to restart a server, or do kind of do basic supervision from the the tool. So like I'm thinking I'm gonna use Backstage again, which I know is not familiar to everybody, but like when we were doing that ingestion, it would be nice to set like to say, you know what, I just want to set my retry to be really low, even though in production,
Mhm.
without having to like go and change a config file. It'd be able to, like, as I'm debugging the process, just interact with the parameters of the operation. Like if there's a
Mhm.
state, like how what my retry interval is, to be able to set that to be really low while I'm debugging.
Mhm.
And so that implies some way that the operations can communicate what can. I mean, I assume we'd use context in some way, but I don't want to get into implementation.
Mhm.
So you're almost thinking, apart from the visualization part of it, almost like we could almost roll in what we have with Simulacrum into this. I know not everybody has the context of that, but
Yeah, I'm thinking kind of like a DOM inspector in the browser, so where you can actually edit the HTML.
Hmm.
So you
But
you can.
not editing and I think that not editing the HTML, because that's a little bit
Sorry,
confusing
yeah.
analogy. I think you mean more like if you want to edit the properties of the I guess that is editing HTML, but I'm thinking like if you want to change the parameters that are passed into a function, or do you mean like I think because there's uh-huh.
I think maybe I don't know, something like that, like setting properties. But I'm imagining, I don't want, like you said, I don't want to get too into implementation land, but I would imagine you'd have to the operation would have to be able to declare in some way which things could be inspected, which things are inspectable.
I think it depends. There's two different paradigms. There's this like changing the CSS,
Hmm.
um, and then there's also the debugger.
Right.
Um, so they are a little bit different because debugger you can inspect the running process, but they're similar, but it's just a
Hmm.
little, kind of also different. Um, so I think more like I think the React inspector is probably the most like what we'd probably want, because you actually have like a tree, and then you have state, and then I don't know if you can actually modify state in React Inspector, but something of that nature.
Hmm.
but um, I think one of the important bits is the state over time, and I think that partly falls back to I think it was Eric, you brought up finite state machines and modeling it like that. Um, but also, I think that sort of serves the purpose of what Charles is trying to get out of it, where we want to be able to, well, once we're sort of filtered in and scoped into the piece of the code that we care about, we want to be able to make a change in our code and rerun it and see how that has affected it. So it's the I think being able to change something and rerun it and see how that changes over time again, and compare those
Hmm.
two like state trees. Um, that's sort of the basis of a lot of this, where we want to be able to change it, see how our change affects it, and see how um, it's like snapshots wouldn't just be sufficient by themselves.
Yeah,
So
I think
having a
I'd like to
history of
see a
it.
timeline view. I think showing a
Hmm.
timeline view as well as the tree view. Um, would be really in the understanding the structure or the timeline view. Yeah.
I have a quick question. When referencing the interacting with running tasks, are you imagining being able to do this in a production environment, or is this development only?
Certainly for logging, I want to do it in production.
Okay,
I
more
don't
specifically,
know.
mutating the
Yeah.
task. Like, is this a production thing? Because that sounds to me harder than doing it in development, but I could be wrong.
I think
Yeah,
mutating a task running a production, that's probably not something you would want to be able to do in the near future, because it's because doing that well is going to require probably at some point doing a code push, because you don't want to be able to willy-nilly just going in like, FTP of state management and running processes, just go in and just edit running processes. So I'm guessing just probably at least not at this point.
I
Well,
could
I-
imagine
it's
if you have
anything
like a running, if I'm thinking functions as a service, if we implemented functions as a service using Effection, I could imagine a world where a task is misbehaving and it's causing wider issues to where you'd actually want to just shut the task down completely and not let it recover. Because if you have, if you do like a retry and the retry was not implemented with a good enough back pressure, and it's just like it restarting and failing and restarting and failing and in this infinite loop, I could imagine a world where you'd want to shut it down completely. But beyond that, like being able to mutate the context, for example, and then restart the task sounds scary in a production environment. And I'm curious how many people would actually do that. So yeah, I mean, that's,
I think if you were attached, it would be akin to like, attaching a debugger to a process running. Like you wouldn't really, would you use a node debugger of a process in production? I'm not sure what that would even mean. So, but it brings up an interesting point that we might want to, use the inspector API or have some set of APIs like logging clearly want to be able to mute. Like so this is one of the things I'm imagining is, well, I don't know. I don't know. Let me just take that back.
I think the context or the context is important behind the intent too, because what we would want to do is going to be different on the front end versus serverless versus server full. The like in the context of front end, you could test it in production, but just be running the front end code locally and hitting all the production services. Like that might be sufficient for the needs. But when you're talking, something like serverless, it's or functions as a service type thing, you sort of have a start and an end, and it's not a long-lived process. So being able to like, when you take a like HTTP request there, if you spin off like a copy of that and have one hit the main service and a copy of that hit your like cloned debug version of it, you could change that and keep getting new input and just have it not actually return any output. I feel like I explained that probably. There's a word for it, like phantom requests. Like I can't think of what I feel like there's a word for it. But where you if you're updating a server or a service and you've done a big refactor and you're trying to ensure that what you've changed or what your refactor has done has not actually changed any of the functional code. You basically run them side by side, duplicate the responses into it, and don't actually take any of the actions. So you just observe that the output of the old service A matches the output of service B, not actually returning your responses to the client.
That's really interesting. I think there's no, what's interesting there. I don't know if this is like directly related to the inspector, but I think what you've described is a really great use of using context to implement contextual effects, right? Like if you were to take, what would be cool is if you have two services, you have your old service and your new service, and then you know, basically all the side effects are have context in between them. You can actually capture all the side effects. I don't. So you can run them. You can run three versions. You could run like the production version. You could run the old one with like capture all the side effects that don't even do anything, and then the new one. And then
I mean, even if you were just recording the input, you could use that input as the thing to pipe into something you're running locally. You know, like knock or whatnot, where HTTP interceptors grab a chunk of input that you can just continue to replay and check the output.
Right.
So, well, long story short, I feel like that would probably be the way that we would want to be able to, you know, mutate production-like code or production-like environments.
I think one of the use cases that we like in terms of things that might be useful early on. What do you guys think about being able to include some kind of like like a stack trace? You know, when you get an error, like a stack trace, or you know, you reach a point where like you have a failure. A stack trace is helpful, but it's really just like, you know, it just like tells you, you know, this part of the road there was a problem, but it doesn't really tell you like why at this part of the road there was a problem, you know. So if we could include with the errors something that you could load into your, like, you know, in local development, like include that as with the you know, you could like, you know, the workflow would be something like, you know, when you get this error, it gets caught, then you include that with an issue. So when the developer goes to troubleshoot, to figure out what the problem is, they could just take that and like load that into their environment and like see like, oh, that's what that looked like when a failure happened.
I think that's going to be. I mean, I think what we can do is you can capture the context at the point of the failure. So you obviously you have the tree where the error occurred, and so you can read all of it. You can read the entire context and attach that to the error. That would be really good for error reporting. As far as like reconstructing the entire tree inside the inspector, might be difficult because you got stateful things like WebSocket connections and database connections that are going to be, you know, very unique and one-off. But yeah, that's I think capturing more data with the errors, like what was the value of the auth token? That's what there's a security, you know, there's a security concern there too. But about what you actually do want to capture from the context. But I think that's something useful to consider. I think one thing too, when it comes to use case, I want to hear from Warren, because you know, it's been your enthusiasm that's like kind of driven us to this point for like saying like, hey, we need an inspector. I want to get into the internals and like learn it so that like I can make it happen. So I want to hear from your perspective about what use cases you have in mind.
Thank you. Yeah, I've been just sitting back because I think all of the points being brought up so far pretty much cover what I'm really interested in. I think the only one that sort of touches on it there is a timeline view. Something for me is profiling at a higher level. So, you know, I don't just want to run the V8 profiler to look at fine-grained memory statistics. I'm looking at higher level things like if I'm running 200 HTTP requests, is there a way that I can optimize, you know, are they currently running serially and I can optimize those to run in parallel? Perhaps I can look at batched parallel Like, you know, so they're much higher level. You know, it's not so much that I want I don't want a V8 call graph. I want something higher level on a timeline to see all of my HTTP requests or whatever it is that are long running operations and how I can optimize that way. Another one, speaking of logging, is, again, I think you get this, I'm sure we've all done this sort of thing where, you know, you're dependent on an external service and you put loads of verbose logging in to say sending HTTP request to URL with method, and then another explicit log statement say got response 200 OK response payload blah blah blah. Whereas if there's a way that you can just implicitly log the fact that you're sending an HTTP request or any operation that has a certain set of inputs and you get a certain value back, if that's being somehow tracked and logged implicitly, it makes your code a lot less verbose because you don't need to add explicit logging statements all over the place. You get a lot of that sort of stuff for free. So just being able to observe the activity of your application gives you logging. Or another way of looking at it is perhaps things like, you know, a Pinot adapter. Again, I don't want to get too bogged down in implementation details, but perhaps you don't want a full-blown inspector running, but you want to use the same mechanisms to track your application activity and write it to standard output when running under a particular profile.
Right. It's
So,
interesting that for things like WebSockets and for XHRs and fetch requests and stuff, it's interesting to me that like runtimes don't, I mean, the browser does that for you essentially. But Node, there's no way to, I'm kind of shocked now that you mention it. This seems like a very obvious feature to include with Node. And with
well, that's, I mean, that's a great point. Is the fact that, when you're writing a front end application, if you want to inspect what your app is doing, what HTTP requests it's making, you don't add a bunch of console log statements everywhere. You just go to the network tab and you can see what it's doing that way. So it's that sort of idea that logging in some ways gets abused. Or rather, it's the only facility that we've got when writing server applications to observe that kind of stuff.
I guess it'd be kind of like I/O, right? Like it's like, you know, there's like a variety of different things that are, it's things that are going in and out of your process.
Right.
It almost sounds like we want to be able to easily flick a switch and get basically get traces. So, you know, in any of the like observability platforms like Sentry or whatnot, where they have...
that's a really good point. That was another one that I wasn't sure if I was going to bring up, but it's the idea of using again, whatever mechanisms are present to implement an inspector can also be used to implement open telemetry or Zipkin or something like that. So again, you can have your operations marked as spans that get shipped off to Zipkin or wherever, or any other APM system.
I think on top of that too, the anytime you're working with like these event-based systems, just throwing a console log in there can get really noisy. So I think apart from just being able to grab traces, having some way to be able to also visualize that. I mean, some of the platforms like Sentry or any of the open telemetry platforms have ways to visualize that, but they don't necessarily represent those logs in the, you know, like in an affection tree type situation. It's sort of the span, you know, point A to point B is what you're logging and observing, and that's your trace.
Yeah, it'd be really very cool if it could include so if you are doing something like you know, OpenTelemetry or Zipkin, then because right now, like, what happens is that you get most of the time you get the traces, they have like boundaries, like you see it at the service boundary. Like, I hit this service, maybe there will be a few spans in between, but most likely it's just like it's going into this service and it's going out, or it's going to this other service. But being able to break that down through, like, this is the code path that it followed, and then it went to that service, that would be really, that I think is a default functionality, could be really helpful default for the kind of telemetry tracing tooling stuff.
Wow, yeah, that's good. Are there anything else that we can think of? I mean, we don't have to if it's. I mean,
Something else I just wanted to mention, not for this list in particular, but hopefully if we get time on this call, I did want to do a brief show and tell, if the court will allow. I just wanted to show sort of where I've got to so far on building something super hacky and experimental, just to give a sense of potentially what's possible without modifying the core thus far.
All right.
Yeah, I think we're good. I think we have a good list. Like we don't need to capture
Yeah.
everything today. It's just to get us on the same page about what are the possibilities that we're seeing, and I think eventually we can prioritize based on both kind of our needs and also in part like what would be helpful for general public and.
All right.
Okay.
Yeah, I would say let's do the show and tell, and then we can talk about possible. I'm probably going to want to do most of the design in a separate session, but yeah, or over Discord. But then we can jump into talk about implementation and next steps.
Great. Let me, if it's okay, I just on the subject of telemetry as well. I just quickly got something up on my screen that I'll show as well. So you should be able to see a Datadog on my screen now, if that's working okay.
Yep.
Not quite yet.
Yeah, it's not coming up yet.
Come on. Oh, this is embarrassing.
Just spins. Just spinning.
Yeah, let me start again. Hold on. Let me turn off my camera. Try sharing again. We try sharing a window instead of a screen.
No.
No dice. Oh, let me drop out and come back. Hold on.
Sometimes Discord just needs to be knifed in the back. It needs to be shot in the head. There we go.
There, excellent. Yeah, so just as a quick bit of background, software platform that I worked on, just wrapped working on it in December of this year. Worked on it for 5 years previously to that. It was a data aggregation platform, and so it had to do a lot of going off to third parties and pulling in data. That's why I was so interested in this sort of thing. And we wrote a library called MGFX, it managed effects, in order to manage a lot of this sort of stuff. And one of the things we did in there was we built a Electron-based inspector tool to debug all of the processes that we had running, and you could view the process tree live. You could view a timeline view for optimization. I can't show any of that only because Electron is an absolute bear to build anything, and I haven't built a version for my OS at the moment, so I can't show that tool running at the moment. But one of the things we also have plugged into it is Datadog APM telemetry, so it's shipping off all of this data to Datadog and showing it in the span tree. So we can see these blue traces here. These are our MGFX tasks, and you can kind of see how you've got like the top level task and subtasks, and they're getting treated as spans within Datadog, and then you've got the sort of lower level node operations, such as the HTTP requests. And then the other nice thing is that we've also got cross-service correlation as well. So to the point that somebody else was speaking about there, the way that we've got a Node.js application running this MGFX library that kicks off a task and a bunch of subtasks, and then it goes across to a Spring Boot application to handle all of this stuff, which is then making MySQL database queries. So this is the sort of stuff that's really interesting to me. So I just wanted to show that as one little piece of background. And then the other thing that I wanted to show was
That was just Datadog. That's just Datadog UI, right? Like, and
Yeah,
like,
so that's
okay.
that's Datadog's interface that you're looking at there, and it's just
Okay.
it's consuming data, or rather, data is being pushed to it from both like the built-in Node and Java Spring Boot telemetry libraries, but then we also sprinkled in a little bit of custom telemetry to support that MGFX library.
That's awesome.
I can't go too deep in that because that's actually coming from production application, which although we do stuff like I was to bring that back for a second here. If I was to click on one of these HTTP requests, again, we do stuff like although we record all of the input and output data, you can see down here we do support things like redacting certain key points of information when they're shipped to the logs, so it doesn't leak.
Yeah, this is amazing. It's really cool. Like that's like everything that we were talking about just a minute ago. Would be nice. Like it would be amazing to have. You have that with the.
Yeah, and so and in fact that the library itself and all of the APM integration, that's all open source. It's just we never made a big deal about publishing it because we were kind of barely managing to get that built and build the application that relies on it. We didn't have time to publish it or anything. But yeah, so there's no privileged code there. I can share links to that and maybe do a side talk on that at another time. But the thing I really wanted to get to was talking about the experimental inspector work that I've done so far. If I just quickly bring up this test application, it's really basic here. It's just got a main entry point where we just wait, print hello, wait a little longer, print world, wait for everything to finish, and then kind of just sit there and wait anyway. But you'll see there's no explicit inspector code in this code snippet. And so if I run node with the special import flag, which is again not Dino friendly, and only node 20 that supports this import flag, but this is like the ES6 equivalent of the require flag, so we can preload this particular piece of code here, which is just going to jump in and intercept calls to importing from Effection, and it's going to leave most of the module unaffected, but whenever you import main, it's going to implicitly wrap this main function in like an inspect function, which does a bunch of mutation of internal logic to get it to work. But enough of yammering, let me just run the program. So I run the program, and now it's just going to sit there and wait. It's going to hit that suspend eventually. But what it should have done in the background is launched an HTTP server that is, no, sorry, that's just the WebSocket server. I've also got to go to here and npm npx fossil, and I can get to here. There we go. So this is the UI for this. And so what we have here on the left is like a state tree of our application, which is talking over a WebSocket to the application here. So if I were to, I have to be a bit quick off the draw here, but if I get my application ready, I quickly run that and then reload over here. It didn't quite work, but we should be able to see in the console the events that are coming through to the web UI. So it does sort of get the backlog of everything you missed, and then it streams in any new events that you've received. And because we've just got this linear history, it means that then you could use this slider down here, for example, to sort of be able to step, so sort of poor man's time travel debugging, the way that you can sort of step back in time and see the start of your application, what it spawned, the process, and then each of these events, there is a distinct timestamp that's logged. So you can imagine that on this little scrubber bar, there are little pips indicating the time that you're stepping to. Just show you in the console again. You'll see that each of these events does have a timestamp associated to it. So you can imagine this is T0 when the application first started, and this can be, T plus whatever. And you can also see what event happened at that point. So you can see there are some sort of points in time where more than one thing happens at once, because there are just multiple events happening at exactly the same step. And this is just like a React arborist tree, so you can, I haven't fully styled it in, but you can sort of expand and collapse sections of the tree. And you can imagine that you could maybe click on one of these, and then maybe there'd be another panel that showed more information, similar to what was discussed earlier, where you could get more sort of like a React Inspector style thing, where you could click on an element in the tree and see context values associated with that operation, for example.
Mm-hmm.
Pretty cool.
Very
So-
cool.
Yeah, that is really cool.
Now,
Like,
what
even if I had this for debugging backstage would already be useful. Just this alone. Just
Right.
seeing what's happened. you
Well,
know?
this is so I've got a more complex application that I've not tried this against just yet, mainly because it runs inside a Docker Compose container. I have to export ports and stuff to be able to get it working. But this is one of the reasons why I'm interested in this stuff, is because I've got a moderately complex application that very to the credit of the authors of Effection, it took me an afternoon to refactor it all to use it. But I want to be able to see that process tree for that application, and I want to make sure that all of my little sub processes are all launching correctly, and if one of them fails, if it correctly blows up all of the associated tasks and restarts them and that sort of thing. But I hate doing that sort of stuff blind, so having a visual tool like this would be infinitely useful. All of this repo, I've pushed it to GitHub. I'll share the link in the Inspector channel after the call. I just need to update the README just to sort of show how to get up and running with it. But I would certainly be super keen for folks to take it for a spin and run it against their own. Sorry, again, it'll only work on node-based apps at the moment. But if you dig in and look at how it works, you could probably. There's nothing stopping you from importing the inspect function and just sort of await main and then just wrap your entry point in that inspect function, and run it against anything on a different runtime. That'd be interesting to see.
One thing I'm trying to remember, the way that the V2 inspector worked was essentially if you set an environment variable, it would inspect that environment variable, and if it was present, it would basically start doing it would assume that the environment variable was a WebSocket. It was basically a URL that it could post to. And so then what that allowed us to do is we just had you could just set the environment variable on any node process. And so if you started the inspector and then passed an environment variable, it would be looking for it, and it would just start streaming events to there. So I mean, we can there's strategies that we can. There's lots of different strategies that we can employ to get it started, but this is really, really cool. I'm wondering too, like Taras, you were saying, like in the area of education, I know one thing that is very confusing when people first come to Effection is how aggressive it is about shutting down scope. So like if you have a spawn task and you exit a function, it's that spawn thing, unless you explicitly await it and you say the outcome of this task is a dependency of this operation, it's gonna it's gonna close it down. How could we use the inspector to indicate, like how can we use the timeline to demonstrate that? I think that would be a good use case for like if we're being able to very visually illustrate the subtleties of the system. That would be a good use case for seeing if we've nailed it. Like if you could illustrate and it would be very intuitive and people are like, oh yeah, of course.
Maybe I can show the diagram that I was working on, because there was a few little details that were kind of useful. Maybe we can talk through it a little bit.
And then
Warren, is there anything else that you'd like to? I mean, I think you probably want to look at code, but is there anything else, Warren, that you want to cover? I don't want to interrupt your.
Oh, no, thank you. No, that was all that I wanted to show. Like, if you folks want to dig in and look at some of the code some more, quite happy to. But as I said, I'll share it on GitHub anyway, so you can feel free to step through it and pick it apart. Hands up, mea culpa. The code is terrible. There are parts where, and again, although I'm quite an experienced JavaScript dev, this is the first proper rodeo on generators for me. So there are parts where I'm sure you're going to look at it and go, "What's that idiot doing?" Like, there's two. You can shrink this thing to 2 lines. So there is that, and I've got no pride over the code that I'll be sharing. So feel free to tear it to pieces.
I'll just take 5 minutes. Let me just show you the diagram quickly, just to see, like, so we could kind of look at what. I'll talk you through some of the pieces of it, and then maybe we'll still have some time to look at code after this.
Yeah,
So
I
let me
think we're
just,
gonna we need to start talking about next steps. I know, like, don't we have a meeting at 10? Or sorry, in
No, we don't.
oh,
No,
we don't. Okay.
no, it got canceled. So, okay, so let me just do 5 minutes. Charles, do you want to do this, or do you want to talk about next steps?
Let's do this. We can.
Okay. So what I wanted to do is I wanted to take a crack at visualizing the fancy loading spinner that I was using as an example. And so I was trying to see like what kind of language would be useful in like visual language would be useful in actually presenting the information. So there's a couple. So what I have essentially is this like this blue thing is these are side effects. So these are functions that are passed into the operation. So this is like, you know, imagine this is set state. And so,
Maybe
you
some
know,
context would be really helpful here, because this is actually based on a thing that we developed for a client it was basically a loading spinner that had very complex logic. So, and it's in the example there, but I don't know if everybody's looked at it, but it you know, it's basically you have an operation, you're gonna, you know, it could be long running.
oh yeah,
It could, you know, it's flaky, so it could fail. And so there's this really like basically the UI designers came up with a really complex flow to represent this loading spinner.
you can see. So like the thing that's even the simple thing that like so it shows the loading spinner if it takes longer than a second, and then if it's taking longer than 3 seconds, then it shows, okay, it's taking longer than expected. Then, you know, and then, you know, if it's retrying, and so, you know, just providing like very detailed feedback. A developer who tried this to write this in React, like it was like a real scary mess, and then everyone's like, this is not gonna work. And so then I wrote, you know, I made this like what I was trying to do was when I was designing this diagram is to follow the code flow. So like I wanted to be able to kind of connect the code that we're looking at with the like the code with the diagram. So there's kind of a linear progression. So let me see if I can find. So if we look at the hook, so the hook is essentially the hook is, so this is the main function. So there's like you're setting state, setting the context, and then calling the loader. So here I actually changed it a little bit in this implementation, but it's I actually rolled the setting of the initial state into the function, which is actually better than, so this code is actually a little bit outdated. But so it's so this is the first line, setting the context, and then it goes off to the loader. So now loader is in the context of the main, and then it goes. So when you go into the loader operation, it you know, so then you've got, okay, so you're getting context. So the first thing is get the context. So these white things that are blocking operations that need to happen before it kind of proceeds, and then state transition. So that's this thing here, and then there is and then the loop starts, and now there's a loop. And so the loop starts, and then so the first step in the loop is it starts the spinner. So this is the first step of the loop, is the spinner. So it spawns. So this is a non-blocking. So green is non-blocking, and then it starts a new operation that is bound. Lifetime is bound to the loader. So try to kind of use these lines to represent that, and then you're grabbing a signal. Get a signal here, and then this is the main thing. Like the whole loader is just is to call this loader function. So that's calling this loader function here, and then update. which is, and then okay, so now we've got, there are two cases. Like if it's successful, now it's branching off. If it's successful, then you have success, and then you hold the spinner and you're done. And I try to kind of signify that with these lines that it's actually like ending the main operation. So you're kind of returning back to the beginning. And then if it's not, then you're in the red, which is the failed cases. And so there's, that branches off into two directions. Either it's like you don't have to run the loop anymore because you've finished all the attempts and it goes down, or you're going to continue and then you're going to start the loop again. So I tried a few different ways of, I actually think I realized just I missed something here. Like this halting of the spinner should be here as well. But I don't know, like, what do you, like, I'm curious.
Is the idea to try
first
and
impression,
automatically generate this?
huh?
Is the idea to try to automatically generate this?
I mean, I think before we even get to that point, I think first question is, from the first time that I showed you and now, like, the first time I showed you, did this look like a crazy mess that was like really confusing?
I'll be honest, it was difficult to parse.
Okay. And is it easier now that I explained it?
I think so. Now that I see that, like the dotted lines represent the scope. It's
This by no means.
What's hard for me is mapping the, like, what I'm seeing with the actual code artifacts.
I think this is not like, I mean, this is, yeah, it's, I think it helps to have, yeah, I don't know. I like, this is just an attempt. Like, I don't know if this is, I think this is just a, first try. I want to try making a few of these for different examples that we have, and then just kind of see, what we learn from that.
I mean, what I would love is, I would love to see the retry logic. I don't know if this is even possible, but I would love to see the running spinner, and I would love to see the codes, like, basically where, like, the code blocks being highlighted, because, like, basically you have these code blocks that exist in between your yield points, and it would be amazing to see those be highlighted as you step through, as the code is actually running.
That would definitely make it the whole thing much more, like, basically have like three sections, right? So you have the code on one side, you have we have this visualization in the middle, or like the running thing, and then visualization, and then as the code is running, the result is updating, and it's navigating through this, like, I'm here, I'm here, I'm here, I'm here, I'm here, I'm here, like, I think that would be, I don't know, like, what the impact of that would be. Like, would this be, would having this, people will be like, oh my god, this is like amazing, or oh, that's a nice looking diagram. Like, I don't know if it's really helpful,
I think that's something that the XState visualizer does that, and I think that's a big part of the reason that it sees a lot of love.
Backstage visualizer? I don't even know what that is.
No,
Oh,
it's
XStage or XState.
XState.
Oh, XState. I see. Yeah, I haven't seen it. I haven't seen, like, I've only seen the static diagrams. I haven't seen the actual running diagrams. So maybe it would be.
Yeah, I'll have to show it. We're actually, there's a client, one of where I've been using it pretty extensively for the last 2 days randomly. It was so funny. Like, Eric, you posted that link to Stately, and I was like, wait, I've been using this tool randomly for like 2 days. So, but we should step through it, because there's a lot of it that's pretty cool, where they actually, they show, they do a good job of visualizing the state transitions.
And just so you know, that's a product that they are selling. So
yeah,
we should temper expectations a little bit here.
right.
But yeah, I always reference that. I mean, Terrace, when I saw your diagram, that is immediately what I thought of as X state, finite state machine, something around that. And then brainstorming like, what would that even mean in Effection?
There is an equivalence between state machines and operations.
I was thinking when I made that comment yesterday about FSM, I was actually thinking, what if you provided a JSON and then we generated an FSM using Effection instead of trying to generate a finite state machine diagram off of Effection. I was thinking of the other way. And then if we did that, we would be able to show the progress through the task tree because we have the corresponding configuration, the FSM configuration. And then you could like cross-reference it with the tasks that are running and then see where it's at in that state machine. That's sort of what I was thinking. I don't know how useful that'd be. I look at FSM and X state, and I'm like, I wouldn't use this. I don't know. I just wouldn't use it.
I can just say from like I've seen a very complex, a very complex usage of it, and it gets like it's great. It's a fantastic toy. It gets really hairy really fast when you start to model really complex interactions across a bunch of domains, and the kind of the usefulness breaks down because there's so much noise about state transitions. And this is the thing about, at the end of the day, the state machine for a task is really like, is it running? And what was its outcome? Did it fail? Did it succeed? Or was it discarded? And that is a simple state machine that every single Effection task is composed of. And so you're basically composing and recomposing the same state machine over and over and over again, versus the other approach where you have an infinite number of state machines and you're creating a bunch of bespoke state machines for every single workflow and every single process. And so you have just all this event cognitive overhead. It's just too much. It's like, I requested this operation to start. Now the operation is starting. Now I'm doing this, and like you have to create. Whereas with Effection, even though we don't have a state machine, although for purposes V2, we actually did track a state machine, but it is the same state machine for every single thing. So that's all a long way of saying, we might want to use it, but we have to keep it simple.
One thing that I was sorry, Charles, just want to add one thing from my experiments with visualizing that thing. One thing that I was kind of struggling to capture is finally, like, how do you show that that this happens in finally block? It's
right.
It's like I'm really curious what that looks like. I think there were two things, like when looking at that, we mentioned the client state machine. Like one thing that caught me a little bit off guard is that there's all like when these state machines get sufficiently complex, you get into a situation you have state machines that are in multiple states at the same time. That to me is like, whoa. I'm like, what? How does that work? Like I'm like, I don't know how to interpret that.
Right.
Yeah.
Go
to go back to what we were talking about in terms of use cases, like even showing where the task is, like what yield the task is waiting on, I think would actually be super useful. I know in V2 there was a yielding to property inside of the task, and I wonder if we can somehow not have to do a static analysis, but understand what we're yielding to in a task. I think would be super helpful. Obviously, showing the context would also be really easy and useful. The harder problem in my mind is if we want to show the properties that were sent into a task, because we don't wrap tasks at this point. You can just, you just spawn a function. There's no there's no concept of capturing the parameters that were put into that function. So even just that simple one of like, hey, what were the properties that were put into this task? That's hard. We're probably gonna have to re-architect how Effection works if we want to accommodate that use case. But I do see it as valuable. So something we should think about. I'm sure, Charles, you're already like brainstorming,
Yeah.
but yeah.
I mean, I think there's a couple ways we could do it. One is I wanted to make sure that it was really easy. Like you didn't have you didn't have to wrap every single thing in Effection. So like I think one of the biggest reasons that we didn't include that from the beginning was just to make migration to Effection really easy, because that's not something that you have to do in JavaScript. So it's maybe, it's not something you ideally would have to do in Effection. I think we can do a couple things, like when you're, when we're spawning, you're essentially creating a value. So one way to think of spawn as a constructor, and right now it just takes a function. We could have a second argument, which is arguments to the function. And then, it would, if you want to have inspectability, then when you spawn, you pass your arguments to spawn. And the same thing would apply to call. That's one way to do it. We talked a little
And that's
bit
how
about
Redux Saga does it.
Mhm.
And
People hate that.
I liked it, but
Oh, you
it's
like
not
it.
that simple, because sometimes the thing that you're calling is a property on a response object, for example. And that needs the this context. So you have to do weird things to accommodate that, which is one reason, when I first saw Effection V2 and then V3, I was like, I miss the args, because if you don't have the args as a separate object, then we can't inspect it later and say, okay, these were the args that were passed into this function. But you basically cut through all the BS of call, which we have in Redux Saga, and the typing for it is very complicated. So I would just be wary of that when implementing, if we wanted to switch to that kind of implementation.
I mean, one thing we can do is we can say, so we already talked about getting rid of non-function call. So like call is some sort of function. And then basically what you would do is you couldn't say like, response.json. You would have to basically wrap it in a Lambda. We're getting a little bit off on the weeds. I wanted to talk to one thing about Taras that you were saying, like how to visualize finally, before we move on to this, is that this was how I was able, this is how I visualized finally in that blog post, which is something that I had, because I had to say, like, what is the difference between when you're, what happens when you're doing Control C. And so what's interesting is that, like, with Effection, you have you have this, if we're thinking of them as spans, you have like your main function and your protect function and your work function. That, this is the call stack. And so you have to represent going down the call stack. But then you also have to represent coming up the call stack. And so what's interesting here is that, so this black thing, that's your finally. I don't know how it fits into the other visualization, but I think, like, one thing that we are able to capture in Effection is, when you have a span, what part of it is the actual operation of it and what part is the return. Like we're essentially able to capture the difference between the call and the return.
I think there's probably a way, if I can play around with this some more. I think it's a little bit like, I think part of the problem is like how much language do we want to provide for control flow, like an if statement, like what role does that play in that visualization? I think it's kind of hard. I don't know at this point. There might be, I think it's quite possible that for most of what is needed, like what Warren showed, might be plenty. Like that's a really good visualization. But I'll just keep experimenting with it and see where it takes us.
Okay. So what are our?
I think I think the
Jigga.
bit that I really wanted to pull out, Eric's mention of when we're I think part of when we were visualizing V2, part of what made it difficult to draw was that we were only logging or showing events based on a change in or step into one of the functions. So anytime we were like getting a log out of the thing, we were like slowly constructing the structure. I think that the bit that I want to pull out was the structure is potentially separate from the state or that snapshot in the state.
Which is the case now, right, Charles? To some degree, because we have like the if, like, do you get a structure of the whole tree before it's executed?
We can do whatever. I mean, in V2, or we don't have
In
like
V3.
there is. Do you get a struct? No.
No, we don't. Yeah.
But I
So
mean,
when you spawn, like we don't know that you're going to spawn until you spawn. Like we could do some sort of static analysis.
Mm.
Yeah, and this is one of those areas that, like, again, like with the args, we could wrap everything in like an operation function that just returns a JSON object, and you're yielding to JSON, and then you have this split between a runtime and what your generator function is actually doing, which is how we do it in Redux Saga. It lended itself to some interesting outcomes, but the reality is it wasn't as useful as you thought it was.
Mm-hmm.
Maybe for an inspector, it's more useful because like you could run through all those yield points without executing any code at all. You're just the runtime is what actually triggers the side effects. And when you're running your task tree without the runtime, it just yields JSON objects. And in that way, you would be able to, it's more of a declarative system where you can run through the entire series of generator functions and not trigger any side effects at all and have like a map of everything that's happening before you even run it. But if we went down that path, it would, I think, trigger quite a bit of re-architecting in Effection, and I wonder how useful it actually is.
Yeah, I think it's going to be hard because you're going to just have stateful. You're just by the nature of it, you're going to have stateful stuff that's going to determine how you branch and going to determine the structure of the tree. I think what we can do. I mean, I don't know if you. I think I posted it in the chat the other day that the TC39 source imports is coming. It's a stage 3. Like we might have it in a year. And this is. That would be an option. We can specifically look for spawn points, and then we can actually look for, we can actually find the static scope of the things that are referenced inside that function. And so we can essentially infer the arguments. I mean, that involves a little bit of hand waving, but I think we should be able to do that. But I think we should at this.
I think I definitely see what you're saying, Eric. I think even if we wouldn't go down that route specifically, just considering the structure of there's sort of the two pieces. There's the state and the structure, and I think we've been conflating the two. And so in V2 in Inspector, and then Warren was what Warren showed us. Like, it's great to see the state over time, and we didn't really have that to be able to go back and forth. But being able to, if we log out as we're going through and have data that is the full tree separate from the actual state transitions, we can show the full tree and then have a timeline scrubber that shows going into each of the little functions. Like if those are just two separate pieces of data, I think that it will just give us more ability to visualize it in a pleasing way.
I think we'll be able to do that, right, Charles, with that T39 proposal. Yeah.
So that would allow us to potentially generate something before it runs, right? That's more of a like static analysis, or as it's up front of.
Yeah.
Okay.
And I think that we just need to the thing as we're developing is that you should be able to jump in at any point and be able to see the tree. So like we're just going to have to do. There's going to have to be some. If we're going to have the capability to attach, then we're going to have to ask for a full dump of the tree. Just like give me the whole thing, and then you can send me incremental updates, or we can do. You know, Eric was talking about doing some sort of like virtual DOM diffing. Like that's also a possibility where we're just periodically walking the tree and then emitting diffs to the client. So, but I think
the whole idea of attaching to your task tree, I love that idea. Being able to reconstruct your task tree at your whim, and be able to visualize it, I think is really powerful. But I think also the highest value that we're going to get here with an inspector is the visualization, is the read-only piece of this. And I wonder if that should be the primary like use case. And then everything else kind of falls off as like V2, V3, V4, whatever, however you want to think about it.
I agree. I think we need to converge on something that actually works. I think we should so that's what I'd say. I think it's time to start talking about next steps. And yeah, what we can do so we can put in people's hands as an educational tool, as a debugging tool. Like, and I think that the read-only piece is going to be like basically expanding on what we just saw today is going to be the highest value thing, and making sure that's correct, and that the internal support it so that it's low impact in performance, and and so on and so forth. So what does it mean? Like how do we proceed?
Warren, what do you need? Is there anything you need? I mean, to help you, even driving most of this. So, how can we support you in this?
Well, the first thing, big disclaimer, before I continue anymore, is that I certainly wouldn't want to be considered to be the inspector guy on this. If you'll pardon me, I don't want that responsibility. This is just something that's been a curiosity to me, and it's just been fortunate that I'm sort of between gigs at the moment, and I'm actually starting my next one on Monday. So I've had plenty of time on my hands to work on this, and I'm certainly going to be ramping up for the next couple of weeks on this new gig. So I unfortunately won't have the time to spend on this that I did for the last couple. But having said that, I've just written the README for this code, and I'll share the GitHub link shortly. So hopefully there's at least enough there for somebody to maybe chew on and turn into something much prettier and a bit more robust.
But I think that's, why don't we maybe that's the strategy, is that we just everybody goes this coming week and has a look at what you've done and tries to get it up and running for their own, and we can use that as a center for the discussion.
Yeah, that would be great.
Okay.
Yeah, for me, next steps is definitely implementation details. Like how, Charles, how do you want this implemented? Because I think there's a couple different paths here. And if we limit the scope to read only, I think it does provide us a little more flexibility. But yeah.
Okay, cool. All right, sounds good.
Cool.
Thank you so much, everybody. I can't wait to dig into that code. And there's nothing like working code to center a conversation.
Right. That's one of the things I wanted to do here was at least get something in front of people, even if it is super hacky, just so we can talk about what's possible and how to maybe clean it up and go further. And I'm certainly not wedded to anything that I've done so far. Like if somebody says nope, this won't work, we need to make changes to the core to scale this, then I certainly would be in favor of that.
Yeah, being able to visualize the task tree in a log drain, like Datadog is very cool, and I don't know. I think that is something we could consider a
Yeah.
feature.
Yeah.
Yeah.
So you'll see when you look at the code here, you'll see there's a very distinct there's a strong distinction between the code that actually taps in and mutates some of the internals in order to get this list of events out, and the part which actually broadcasts that over a WebSocket server. So you could theoretically take those events and do something else entirely with them and send them somewhere else. You know, for example, you could just log the events to the console or send them to a logger.
Mm-hmm. Oh, that's so cool.
Yeah, let me.
All right.
There it is. I've just pasted it in the Inspect channel. So yeah, feel free to have at it.
Awesome. Thank you
All
very
right.
much.
Good job, everybody.
Is it do a thing or no? It's not. Doesn't do a thing. Okay. All right. Later,
All right.
guys.
Cool.
Excellent.
All right.
Bye, folks.
y'all.
Okay. Bye.